Welcome everyone. I am Dr. N.S. Srivatchan, Associate Professor of Electrical and Electronics Engineering Department of R&D Engineering College. We are discussing the various topics in electronic devices and circuits. And in this session, we are going to discuss about the working of LED and laser diode, which are very useful in modern real world applications. Now let's focus on to the topic. As we mentioned, we were discussing the various topics in the subject EC8353 electron devices and circuits. And in this session, we are going to discuss about LED and laser diode. LED stands for light emitting diode. Basically, LED is a PN junction diode, and we know what is PN junction diode is. A PN junction diode is a diode when we sandwich a P layer and N layer together. Now, what is the difference between PN junction diode and a LED is, in case of LED, both diodes will work on forward condition, but the main difference is LED where we use the compound materials. So that will be the only major difference in terms of construction difference is concerned. But in terms of operation directions are concerned, both PN junction diode and Zener diode operates in the forward bias condition. Now, we know that when we combine P layer and N layer together, it forms a PN junction. And in the PN junction, when we give a forward bias, recombination of electrons and holes take place, or recombination of charges will take place, or recombination of charge carriers is going to take place. And when holes will, when electrons from the higher energy state falls into the holes, and they eliminate the or liberate the electroluminescence, or we can call it as energy release from higher energy state to the lower energy state, that because electrons are in the going to the conduction band and comes back to the valence band by dropping of the energy, because they are falling onto the holes by means of release of energy is in the form of photons, because we will be using a compound materials in the junction exactly, and thereby it is able to emit the light, and the light are in the visible spectrum. And basically it is a electroluminescence effect, where we, with the help of electrical energy, we are able to produce the light, and hence it is called as electroluminescence. And LEDs are extensively used in display screen, smartphones and computers, and all the latest devices tend to have LED display because of the clarity and better lighting effect which it produces. As we can see, LED contains two terminals. As we know, it is a two-terminal one-junction diode, one-junction device. There is a terminal which is called anode, which is a positive terminal, and cathode is a negative terminal. And you can see there is a glass dome is also present. Now, in terms of construction-wise, as we know, LED is constructed by depositing 3 layers of semiconductor material in a substrate. So basically what we have is the 3 layers as P-type semiconductor serving as a top layer, and this will be the top layer, and you got a active region, and the top layer forms the anode or positive terminal of the battery, which is connected to the positive terminal of the battery, and an active region serving as a middle layer for both holes and electrons, and N-type semiconductor serving as the bottom layer. So there is a active layer, or the layer in which the charge recombination is going to take place by emitting the light, okay, which is with the help of electroluminescence, and it does. And the bottom layer basically contains the N-type semiconductor, and it forms the other part of the lead or the electrode, which is the cathode. So we have got two terminals, anode and cathode, and we have got a middle layer, which is basically a common layer for both of the region, and basically it is going to help, or you can call it as active region, in which case the charge recombination is going to take place. Okay. And now, as we know, the working also, as per the working, before that we'll discuss about the coating is concerned. As we mentioned, the LEDs uses compound material and to provide different kinds of light. Okay, and because when electron, when charge recombination happens, it emits the energy in the form of photons or light, and that light color depends upon the kind of compound material we'll be using. Basically, compound semiconductor materials such as gallium arsenide phosphide, gallium arsenide, gallium phosphide will create different colors. As we can see from the tabular column, gallium arsenide basically it provides IR radiation, which are very common in your PN junction diode also. PN junction diode also emits heat, but it does not emit light. So because it does not use a compound material predominantly, but it emits light, but it is in the IR spectrum. So we can see the heating effect happens in the PN junction diode. Gallium arsenic phosphide is a visible red color and provides visible red color, and gallium, aluminum arsenide and phosphide will provide red, yellow, green, and multiple colors can be got. And indium gallium aluminum phosphide will give you ultraviolet LED in red, orange, and yellow and green. And suppose if we want a blue color, we can use silicon carbide, which will provide blue LED. And gallium nitride will provide ultra bright blue. Like even nowadays, we have many lights which have got a high blue color, right? So indium gallium nitride, we use green and blue. So based on where the light is emitted or how the light is going to be coming out, we have two types of LED construction. One it is called as surface emitting LED. Other one is edge emitting LED. It depends upon the direction in which the light is emitted. If the direction of the light emission is perpendicular to the PN junction plane, it is called as surface emitting LEDs. If the direction of light is parallel to the PN junction plane, which is called as the parallel means vertical, which is called as the edge emitting LEDs. And mainly we have mentioned one more thing. There is a glass dome is there. The glass dome, or you can think of the dome as such, it is used to it is embedded because to reduce the reabsorption problem, and it increases the lifetime or life cycle of the LEDs, and it can go up to 7 years. So almost like 50,000 hours or 2083 days, which we can count into 7 years. So basically LED works on the spontaneous emission, which you mentioned. When energy electrons are excited to a higher energy state, they go to the conduction band and they drop back to the valence band by emitting the photons of energy. So this is a basic working of from conduction band to the valence band. The energy drops off, the electron drops off, and by emitting the photons of emission, that is light is emitted, and the color of light depends upon the compound material we'll be using. This is the symbol of LED. PN junction diode will not have a light symbol that is coming out of it, but LED will have a symbol like this, which means this is. But one major difference between terms of LED and PN junction diode is both are operated in forward bias, but in terms of cut-in voltage, PN junction diode operates at 0.7, but in case of LED, because it is going to operate and produce a light, so that maximum forward voltage in which it is going to operate is from 3 volt to 10 volt. So basically it is going to create such effect, and we can see that we will be getting the VGR spectrum as well, green, yellow, red. So all these regions are happening with respect to the voltage, and according to the intensity of current, accordingly the power circle is also created, and we'll be able to get the spectrum wavelength, as you can see, and in terms of voltage and current, and in terms of intensity, relative intensity and wavelength, we can also see that how the color is being produced. So this is how the LED works. In terms of applications, merits are concerned, it is going to be it is going to light up very fast, and it produces better lighting effects compared to incandescent lamp. And demerits could be in terms of performance, in terms of temperature, operating temperature, where that life cycle is one that has to be properly discussed. And application, we can see it in the opto isolators, indicators and signs, and TV, VCR, remote control, and of course LED, mobile phone and laptop screens, and all the display screens will be using LED. Next topic will be going to the laser. Laser is similar to that of PN junction diode and Zener diode, but one main difference is the kind of energy which is going to come out of it. So laser, basically light amplification by stimulated emissions of radiation. Laser is a monochromatic light where it is going to emit a single frequency coherent light. Sunlight will contain various energy and different lights or different colors have been produced. Incandescent lamp produces single frequency, but it is not coherent. But in case of laser light, it is going to be very, very coherent. So in terms of construction, it is going to have main difference between a PN junction diode, a Zener diode, PN junction diode and LED, and of course laser diode is, there is a slight difference between a laser diode and LED. LED does not have a reflective coating, but in case of laser diode, we have a partially reflective coating on one side and highly reflective coating on other end. So what happens is the photons of energy get reflected and they become a monochromatic or coherent beam as such. So it is going to come out of it. And so the working is similar. It is also operates in the forward bias condition, and electron hole recharge recombination take place, charge recombination take place. When the electrons are in the excited state from the conduction band, it comes back to the valence band by emitting the photons of energy. That energy is in the form of light, and when that light is forced to reflect back and it is made to focused, light is coming out with the help of reflective and fully reflective and partially reflective light, and that light is monochromatic in nature and it is very, very coherent beam. And as like LED, we also have two types of laser diode: surface emitting laser diode and edge emitting laser diode. If the plane of light projection is perpendicular, it is called a surface emitting laser diode. If the plane of projection is parallel or vertical, we call it as edge emitting laser diode. And as we know, working of laser diode is similar to the PN junction diode and LED. When we apply a forward bias, a charge recombination happens. Electrons are at a higher energy state. They fall back to the holes by emitting the photons of energy in the form of light. And since the photons of energy are forced with the help of reflective coating, and they are forced to come out in a coherent beam, that is a laser beam. And of course, the operating voltage and free current value will be much higher compared to a PN junction diode. As we can see, they operate at a higher value. Main drawback in terms of laser diode could be in terms of the operating temperature, in terms of light intensity is concerned, because temperature and light intensity are inversely proportional, because as the temperature increases, the light intensity decreases, because semiconductors are subjected to temperature variations as well. Now the merits are, it is going to be, we can create a low power, laser light can be created with the low power operation compared to non-semiconductor laser, which requires high power. Manufacturing, they can be manufactured in arrays as well. And demerits is, and of course it requires heating problem. It calls for heating, it has got a heating problem. And application wise, we see all the time for a medical purpose, for a laser eye surgery or other medical surgical equipment, laser equipments are used for it, or for skin treatment or dental treatment or eye treatment. All these treatment will be using laser, and also of course in industrial process we'll be using laser cutting tool, and also for laser welding also, which will be used in industrial process. So, and also used for surgical operation for cancer, cutting removal of cancerous tissue from the human body. So laser treatment is also there. So, and CD and DVD players also there. So these were the some of the working and operations of laser diode. And in this session we have covered LED as well as laser diode, and of course these are all basic extension of PN junction diode. So once we are thorough with the PN junction diode, we will be able to understand. And all these diodes operates in the forward bias condition, and only difference is the way in which the energy is made to focus. In PN junction diode, we don't have any reflective coating. In laser diode, we use a compound material, but still there is not much of a reflective coating. But in case of a laser diode, we do have a partial and fully reflective coating material, and which makes the diode emit a very, very focused beam as a laser beam. Okay, so I hope this video is very useful and interesting, and thanks for watching. We'll be having meeting in some other video. Thanks for watching.